In this tutorial, we'll look at graphing functions. Consider f of x equals 8 minus x divided by x plus 4. Determine the domain, find any vertical or horizontal asymptotes, find the intervals on which the graph is increasing and decreasing, and locate all relative extrema. Find the intervals in which the graph is concave up and concave down, and locate any inflection points. And finally, we'll sketch the graph. For part A, we have to determine the domain. Note that x cannot equal negative 4 because that gives us 0 in the denominator. So on your number line, here's negative 4, we cannot choose that value. That means that the domain is everything but that value. So we write negative infinity to negative 4 union negative 4 to infinity. Another way to write it is all real numbers except for negative 4. For part B, we need to find vertical and horizontal asymptotes. First, we'll find a vertical asymptote. This is found by setting the denominator equal to 0 and solving for x. Now for the horizontal asymptote, we need to look at the limit as x goes to positive infinity and the limit as x goes to negative infinity. I'll leave it to you to verify that in both cases we get negative 1 as an answer. That means that y equals negative 1 is a horizontal asymptote. For part C, we need to find the intervals in which the graph is increasing and decreasing and locate all relative extrema. Let's recall what f of x equals. Now for increasing and decreasing, you need the first derivative. The first derivative uses the quotient rule. So we'll have low d high minus high d low all over low low. After simplifying, we obtain negative 12 over x plus 4 all squared. This does not equal 0 since negative 12 never equals 0. So we have no critical points. On our number line from negative infinity to positive infinity, we only have negative 4 that can't be used because it's not in the domain. So we'll make our sign chart around this value. First intervals from negative infinity to negative 4, and then from negative 4 to positive infinity. If we plug any value from the first interval into the first derivative, we get a negative answer, which means the graph is decreasing on that interval. Any value in the second interval is also negative, which means the graph is still decreasing. In this case, there are no relative extrema. Now for part D, we need to determine intervals in which the function is concave up and concave down and find any inflection points. This process is the same as above, except it uses the second derivative. So let's recall the first derivative. I can rewrite this in the following way. then the second derivative is found by using the chain rule. I'll rewrite this. This can never equal 0 since 24 doesn't equal 0. Again, there are no critical points. So on our number line, we only need to be concerned about -4 because that number is not in the domain. So for our sign chart, we go from -infinity to -4 and -4 to positive infinity. This time we write f double prime of x and f of x. If we choose a value in that first interval, f double prime of x is negative, which means the graph is concave down on that interval. If we choose a value in the second interval, from -4 to positive infinity, f double prime of x is positive, which means the graph of the original function is concave up. But remember that x equals -4 is not an inflection point in this case because -4 is not in the domain of the function. This is the graph of the function. Notice at y equals -1 we have the horizontal asymptote, and at x equals -4 we have the vertical asymptote. Recall that on the interval from -infinity to -4, the graph was decreasing and concave down. Then from -4 to positive infinity, the graph was still decreasing, but it was concave up. And this completes the exercise.